Hello, this is Adnan Sanni from Sanni Enterprises, and we are following up with the logical hydraulic troubleshooting. The title of this video is checking faults. What do I check? What do I check with? What do I expect to read? Where do I check? Checking faults. The troubleshooting procedure in this book will endeavor to answer the following questions. What do I check? Which things can be measured in a hydraulic system that will indicate where the problem lies? A doctor will very often check a patient heartbeat and temperature when making a diagnosis. To what do these correspond in a hydraulic system? What do I check with? Knowing what to check, it is then necessary to determine any special instrument or equipment that will be required corresponding to the doctor's stethoscope and thermometer. Where do I check? Whereabouts in a hydraulic system is it necessary to carry out the checks, and which should be done first? As mentioned, doctor will very often check a patient's heartbeat, that is the human pump. Should the hydraulic pump be checked first? What do I expect to read? Having taken measurement at certain point in a system, it is obvious necessary to know what the correct reading should be in order to draw conclusion. If the reading is any different from normal, again a doctor knows that the body temperature should be 37 degrees C. So if there is any variation, a diagnosis can be made. What do I check? Hydraulic system is a means of transmitting and controlling power. Mechanical power is a function of a force multiplied by distance moved per second, or force into velocity. If a hydraulic actuator is considered as a device to convert hydraulic power to machine power, then the force or torque exerted by the actuator is governed by the applied pressure, and the velocity or angular velocity is governed by the flow rate. It follows, therefore, that flow, pressure, and the two basic elements of hydraulic system that control the power output. In engineering terms, velocity usually implies both speed and direction. Speed, as discussed, being controlled by flow rate, and the direction of the actuator movement being controlled by the direction of flow. The three factors, therefore, that transmit and control power in a hydraulic system are flow, pressure, and direction. And it follows that in order to assess the performance of a hydraulic system, one or more of these factors will have to be checked in order to decide which it is necessary to obtain the full facts of the problem. Very often when a problem is reported on a machine, it is described in various terms, such as lack of power. As previously mentioned, power is a function of both force and velocity that is necessary to define the problem in terms of one or other in practice. Relevant question must be asked in order to determine exactly what the problem is. That is, when lack of power is reported, does it mean that the actuator is moving too slow, or is it not giving the required force or torque? Having defined the problem as one of speed, force, torque, or direction, it is now possible to define the hydraulic problem as one of flow, pressure, or direction. Although the troubleshooting procedure is based upon checking the flow, pressure, direction, there are other aspects of a system which can be measured both as an aid to locating a failed component and also to be determined the reason for a component failure. Such properties are negative pressure and temperature. Negative pressure, especially in the area of the pump inlet, to check for problems in the suction line. Generally, when one component or part of system is hotter than the rest, it is good indication that flow is taking place. This is Adnan Sanni from Sanni Enterprises. My WhatsApp number is 00923124225402, and my email are adnan_sanni@yahoo.com and sanniadnan@gmail.com. 24/7 365 free helpline for Vickers Eaton hydraulic customers in Karachi, Pakistan, or all over the world. And this is the logical hydraulic troubleshooting manual. If anybody needs a copy of it, kindly contact us on the email or WhatsApp. We'll be ready to ship it. Thank you. This video is a tribute to Mr. Harry Vickers, who started this Vickers and designed the Vickers first wind pump. God bless Mr. Harry Vickers.